waves, right? And you could do this, right? Huh? What? Yeah. Make your pinna bigger. I'd like you to know the parts of the pinna. This little dangly do right here. Lobule.
What?
Lobule. This is just anatomy. Lobule. Okay. And then at the very top is called the helix. Helix is the top. Dangly do. Lobule. All right. Now, add one thing. Haven't you always wondered? I want to know what this little flap is right here that you can plug. It's called the tragus. The reason why that's important, and sometimes you check that in babies, and you see if they have a middle ear infection. You give that like a little push, and then they're like, "Oh my gosh."
Never seen that. Tragus.
Is it also going to be just strictly anatomical?
Strictly anatomical. All right. The pinna, though, that's the one that collects the sound waves, yes? Okay. Remember the whole hearing aids was like the little cone, right? What, honey? Okay. All right. What happens to your ears and your nose as you get older?
They dangle.
They get bigger. They dangle. Yeah. It's true, because you're bigger. You guys remember Ross Perot?
No.
Okay.
What was it?
All right. External auditory meatus, that's just the passageway for sound waves. Passageway for sound waves. And it's lined by ceruminous glands. What's the fancy name for earwax? Cerumen, right? Just turn that into cerumen with an E there. And what's that earwax for?
Antimicrobial.
Antimicrobial, anti-insect, yeah, just anti-cootie. Not that much usually. Yeah.
It's more of just protection.
More of like antimicrobial stuff, yeah. Although you'll still see some like homeless folks come into the ER, they'll have like little bugs crawling out of there. It's so sad. Yeah.
Their cerumen isn't doing their job.
Cerumen's not doing their job, it's just poor hygiene. Alright, ceruminous glands. By the way, if you're lucky enough to have a Y chromosome, you're what, a male or a female?
Male.
You're male. On, or not lucky, on that Y chromosome there's about 70 genes. One of those genes is codes for ear hair. Okay? So there's ear hair. You ever see like older folks have a little bunch of ear hair? And I swear that gene turns on when you get married. Once you're married, that gene is just going crazy, and it kind of makes
Ugly
sense
gene.
because the wife is like helps to muffle the sounds. I think.
Do it right the first time.
Right.
Make sure nobody wants you ever again.
Yeah.
You're
As
done.
I get older, I'm just gonna continue it with the beard. You know, just do like a full. Built-in earmuffs. Yeah. Earmuffs. All right. Then we're in the middle ear, the mitta. Okay. That's the middle ear right there. The first structure, so on the practical, so on the eyeball will be tunics, 3 tunics, right? And then for these, I'll ask for like a region, yes? Outer, middle, and the inner
Inner
ear.
ear.
When we go to the middle ear, the very first vibrating structure is the tympanic membrane. Basically the first vibrating structure, right? It will vibrate. First vibrating structure.
So when you blow your eardrum, it just reheals, right? Or but you can still hear sound.
It does reheal. You can, but sometimes it'll be muffled. You won't get a complete, frequency. Yeah. Now the very tip of the eardrum is called the umbo. I like that because this is the part that articulates with the hammer or the malleus. Call it the malleus. Hammer time, right? So that very tip of the tympanic membrane, let's say our got the hammer pants. Yeah.
They're coming back.
Are they?
Mm-hmm.
Should have never gotten rid of them. So that will that will articulate with the malleus. All right, here's the malleus. You guys will have. You guys have something that looks like this picture? This has a nice three. Get this picture out. Malleus, incus,
Stapes.
Malleus, incus, stapes. Three in a row, right? Malleus, incus, stapes. Those are called your ossicles. Stapes is the one that has this little, it's like a little stirrup where you put your foot in, like a horsey. Okay. Incus. My daughter. These little things here, this is their size in real life. Look how tiny these little bones are. Crazy?
That's kind of big, yeah.
It's not that big, look at it. It's tiny. From
I
here.
can see from here, it's pretty big.
Yeah.
They're like this big.
Not what she said.
All right. So, what's the first vibrating structure, right?
Tympanic membrane.
Can we get rid of this?
Yeah.
Because they're just going to call that like the middle ear, right? So nix that. Okay. Let's talk about this real quick. See this little drain tube right here? Okay. So that's going to drain the middle ear. You can call it the eustachian tube or the auditory tube. Don't call it the auditory canal because this is the auditory canal, yes?
Mm-hmm.
So call it the auditory tube or the eustachian tube.
Drains
So that's
middle.
this guy right there. Okay, let's do the function. You guys ready for the function?
Drains the middle ear.
So that's going to drain the middle ear. Also, it'll help to equalize pressure between the middle ear and basically the outside. You want to have the pressure the same, because if the pressure is not the same, the tympanic membrane won't be able to vibrate, okay? So as you go up, you're driving up to Tahoe, right? There's less pressure here than there is in here because you were at sea level. So this thing isn't going to be able to vibrate against a high pressure area. So how do you equalize the pressure? What do you try to do?
You blow out your ear.
Blow out your nose, pull on your ear, chew gum, right? Yawn.
Is that not good to do that?
I mean, if it's slow, you want to kind of take it easy. There was one guy recently who just like sneezed and he had a stroke. Max laughs.
It is true.
Don't laugh at your patient, please. Okay.
I was
Yeah. What?
I was in our library and some guy yawned and had a seizure. And like everyone was laughing because he yawned
Here?
super loud, yeah.
Maybe that was the start
And
of
he was
it.
like going like this, he's like, ah, like super loud, and everyone started laughing, and then he fell back and had a seizure.
That was his seizure, the start of his seizure.
Crazy.
Usually when they do that, they.
So loud, he yawned so loud.
Wow.
Yeah, and then just, it was crazy, and everyone's just sitting there in the library like, what do we do? Yeah.
Wow.
Paramedics came and stuff.
Dude, watch now, he had a pencil in his mouth, he had to like flip it over and stuff.
I think with a seizure, you have to wait to have it.
Yeah, they don't like
Yeah.
you gotta let her tongue, stuff like that. Yeah.
I mean, yeah, you kind of.
Did they have a bracelet? Like a little
I don't
medical
remember,
ID
like that was
thing?
when I first started coming here, and I was
Yeah.
like
Yeah.
17, and I was like half laughing, then I was like, oh shoot.
Yeah.
But different,
Okay,
you know?
we got the functions.
Helps equalize pressure between.
And drains the middle ear, right? Who has a more horizontal, shorter eustachian
Babies
tube?
and toddlers.
Babies, right? Because when they have a throat infection down here, they could also get what?
Ear infection.
Otitis media, which is the #1
What?
cause of baby admission to the ER because of the
The middle ear and the
infection.
outside.
Unless you are doing what to your baby?
Spanking?
Breastfeeding. Breastfeeding.
No.
So when the baby's
it's like
breastfeeding, there's a lower risk because the baby's got to work harder to suckle mom, and that will help to pull and yank the auditory tube. Okay. All right. So here's a normal tympanic membrane. You guys look at each other's ears,
No.
and then this is one that's inflamed.
You can really see that
Okay.
far in.
There's also, by the way, otitis externa, which is called swimmer's
Swimmer's
ear.
ear.
Okay. All right, now let's go to the inner ear. All right, did you guys label these already? Malleus, Hammer. Incus. Anvil. Right, the hammer's like beating on the anvil. And then what's the last one?
Stapes.
Stapes or stapies. Okay, all of these you can lump the function. They're all going to vibrate in response to sound. Malleus, incus, stapies are all going to vibrate with response to sound.
So
But
if you were to do the stapes and you wanted to do the over window, would you say what is the stapes attached?
yeah, let's talk about that next. So the stapies has a special function. It'll actually push up against this window that's, by the way, oval shaped, called the oval window. So it's going to push in on the oval window. So I do like that. And that's important because inside of your cochlea, it's liquid, but where is sound normally transmitted in? Not liquid, but air, right? What's harder to push, air or liquid?
Liquid.
Liquid, right? So that's why this little window is about 16 times smaller than the tympanic membrane. It focuses all the energy on a smaller surface area. Okay. So again, stapies, that's going to push in on the oval window. But when the oval window is pushed in, how do you cancel out the pressure?
Can you say it again? Sorry.
The round window. Yeah. Which part?
Just the pressure, because sound travels better in sound or in the liquid, but then so you need something bigger.
But actually creating the pressure waves, like the onset of it, it's going to be harder in the liquid. But once it is started in the liquid, it does transmit easily. Yeah. Okay, so let's do this right here. Did you label this one?
Round
This is the
window.
round window. Okay, and I'd like you to know the function of the round window. That round window will offset pressure created by the oval window. So when this pushes in, what do you think the round window will do?
Come out.
That'll push out. So yeah, offsets pressure created by the oval window. It's kind of like a waterbed, okay? Push down on one side. Those were big in the 80s, okay? And then the other side.
Especially with cats.
What?
So is there ever a problem with that, like with that rupturing? Could that rupture?
Yeah, I mean, if they're, that membrane.
Yeah.
All right. So oval window.
Okay.
You have something that looks like this, maybe? Yeah,
Wow.
It's round.
that's profound.
Oh.
And then the oval window is this. You guys have that one too?
What was the
Yeah.
function?
Maybe itty bitty.
Function of the oval window again?
Oval window is basically what's pushed in by the
Oh, okay.
stapies.
Okay.
Yeah,
It's a really tiny
So this is
picture
a
of the
smaller
color.
ray for the round.
it's a smaller one. Yeah. Yeah, boy.
That's. So we're gonna
Okay. Do you guys see this little tiny muscle here?
Yep.
It's actually really important. One of the muscles is the tensor tympani, and then the other one's the stapedial. You guys see stapedial on your list?
Mm-hmm.
Okay,
Number
16 and 17.
Okay,
Okay, label that guy, label that muscle, and then we'll talk about the function in a sec. Here's the thing, this is the tensor tympani. We don't really have a good model that shows the stapedial, so the muscle that we'll tag is this one, okay? Tensor tympani. Okay, let's do the function. So here's the thing that's really cool about this. When you hear something super loud, right? That wasn't super loud, but when it is super loud, what will happen is that this muscle will contract and it'll dampen the vibration of the ossicles. Why would that be a good thing if it's a super loud sound?
You know,
Protection.
Protection from hair cell damage. The hair cells in your cochlea, once they're gone,
They're gone.
they're gone forever, right? So as you get older, you can't hear the high frequencies, like dads, okay? So, let's repeat that. So with loud sounds, they contract, it's like a reflex basically, and that dampens vibration to decrease damage basically, okay? Not to say it's 100% though, right? I mean, because these muscles, if it's a constant loud sound, you're at a concert, well, all muscles do over time. We're thinking fatigue, right? So eventually they're gonna get vibration and stuff like that. And you know, if it's like a gunshot, I mean, some of the vibration is gonna happen initially first, so there can be some initial damage. But it's trying to reduce the damage. Yes? Okay.
So with the shearing, it actually does shear the hair like eventually from overbending or from?
Yeah, it's just, it's probably just, eventually they just get overstimulated, they stop releasing their neurotransmitter, and that cell just dies from overactivity. There was a student, actually in my other class, and she smashed her cheekbone when she was a kid. And from here on out, that area is really numb on her cheek. Here's the weird thing that's happened, right? So whenever she puts makeup on, she says she can't hear in that same side of her ear. It's like the sounds go away, all right? What should do sensation to your cheek?
7.
What cranial nerve?
CN7.
7 does motor to the facial, right? To the muscles. So it
Abduction.
should be 5,
Trigeminal.
V2.
2, right? V2. So here's the thing. So when she actually damaged her cheekbone, she actually damaged her 5-2 as well. 5-2 does sensation for this, but it also stimulates the tensor tympani. So she had some probably repair over time. Now she has just this weird rewiring that happened. Okay. So when she strokes her cheek, well, that area is numb, those fibers are dead, but they almost got rewired to her tensor tympani, caused the tensor tympani to contract, and she gets a dampened hearing on that side of her ear. Isn't that weird?
That's kind of cool.
It is kind of cool. I mean, it's not like devastating for her life, but she just gets this weird effect.
Right.
All right, that's the inner ear. That's a mislabel there. Now, here's the thing. When you think about like the inner ear, it's almost like a pen, in that you have something like really.
You need one?
I want one that I could open up,
I got
Kind of like that.
like a ballpoint pen thing. This is all like pencils and stuff.
Is it like that?
Is that open? Okay,
I
thank
just
you.
pulled off the, yeah.
All right, so you guys see how? Well, I'm gonna have to. I don't want to break it.
Let's do it.
So there's an outer part that's hard, right? And then there's this inner part. You know what I'm talking about with the ink in it,
Yeah.
right? That's really flexible. Okay. Thank you.
Oh, it's
It was an amazing demo.
Mm-hmm.
So in your inner ear, there's this harder outer part. That's the bony labyrinth. Okay, so this is more for the structure, and this is the strong part, right? The 19, that bony labyrinth, that's going to be filled with perilymph. Okay. This is the outer rigid structure. And what bone would that be in? Temporal bone, right? So in your temporal bone, there's this petrous portion that's really hard rock, okay? Protects that inner ear. And then inside of it is a membranous labyrinth that's going to be smaller and more flexible. So instead of perilymph, what fluid is inside of that?
Indolent.
Yeah, so that's going to be endolymph inside. The membranous, that's like the ink, right? Equivalent. Okay, this is a biggie here. Do you guys have this particular picture? This has a bunch of junk on it. Alright. The outer part is like tan beige, right? That's the bony part. You guys agree this is all inner ear?
Mm-hmm.
Okay, looks like a little snail shell that's mutated. It's the bony labyrinth. My daughter's an only child, so she'll like pick up snails from the garden, put them on her bicycle, handlebars, and like ride them around the neighborhood. She'll name them too.
Turbo.
Yeah, it's a good time. Okay. All right, now within the bony labyrinth, there is fluid, and that fluid is going to be the perilymph. Now, what color is all this stuff inside?
Pink, red.
It's like gray,
Oh.
grayish, right? So that's gonna be which labyrinth instead of bony?
Membranous.
You betcha. Membranous labyrinth. Instead of perilymph, what would be inside? Endolymph.
Endo.
Okay. All right. Make a note that the endolymph is what's actually bathing your hair cells. So your hair cells is in this special compartment that has endolymph bathing the hair cells. Okay. Now, let's talk about the three main parts, right? We'll take a break in a little bit. So there's the vestibule, semicircular canals, cochlea, right? So we'll do that again. So on the practical, maybe I'll ask you for regions. There's 3 regions again. What? God loves 3. Okay. So vestibule, semicircular canals, cochlea. All right. Good. Let's go to the vestibule. Now, turns out the vestibule is made up of 2 compartments within it. One is for linear acceleration, like on a flat plane, and then one does acceleration more when you're going up and down like an elevator. All right. So, what are those 2 compartments? Utricle, and then the saccule. Yep, good. So the saccule is right next to the cochlea. So this is where we can tag it. Those are those 2 compartments. Utricle, saccule. I'd like you to know that they both contain the sensory receptor known as the macula. Okay? Is macula on your list somewhere?
Yeah, pretty sure.
Or at least it will be when we look at it under the microscope after the break, okay? So, contains both of them, you could bracket both. They both contain the sensory receptor known as the macula, alright? Remember the macula is the one that had your ear rocks, right? The otoliths? Okay. Alright, let's try to finish up this model and we'll take a break. So, utricle, saccule. What's this overall region again? The vestibule. And inside of both of these are the ear rocks. Okay? That's why the ear rocks can fall off and then they look at what they can go into. The semicircular canals, right? To cause the spinning, the vertigo.
Would
Yep.
If enough of them got in there, would it cause some type of jam?
If I'll like
Actually?
clog it up a little bit. The rocks are really, really tiny. Yeah. So it probably wouldn't cause a jam. Okay. There's this. I think it's really tiny on yours.
Yeah.
Yeah.
Alright.
Yeah.
Oh.
But it's actually fairly big on the real model. It's this, look at this one here.
21, 26,
What's on here what I like?
I mean, that's pretty.
That is, how tiny is it on yours? Like super, super tiny?
It's super tight.
It's really small.
Alright.
Depends what we're tagging on.
Yeah. So let's tag some of the obvious stuff. You guys see the white part? Is that bony or membranous?
Bony.
Bony. And then what about the baby blue?
Membranous.
Membranous. Okay. I like this thing. I like tagging this thing. What is that coming off the cochlea?
Vestibular cochlear nerve.
CN8? Which branch if it's coming off the cochlea?
Cochlear.
Could it be the cochlear branch? Yes. Okay. So on the lab practical next week, it's next week, isn't it? You can say the number, the name, but I'd like you to know this is the cochlear branch of CN8. Yep. Okay, let's do one or two more things here. This is a good place to tag this thing right here. See that little triangle?
Are those a hair cell?
This is the saccule.
Oh.
Tag that dude too. Saccule. S-A-C-C-U-L-E, right? What sensory receptors within the saccule again? The macula. Not the Dracula, but the macula. Alright, so you got ear rocks in your head, look at that. Shearing. Hammer, hammer. Semicircular canals is the outer part, and the semicircular duct would be the inner part. So the canals is part of the bony, and the ducts are part of the membranous. So again, it's just this idea that you have this outer tube that's rigid, and then inside there's one more flexible. That's the membranous part. Okay. One more thing on here. You guys see how this is like kind of enlarged a little bit? That area is called the ampulla. That's on your list somewhere, right? Okay, ampulla. This is this dilated portion, and that has another sensory receptor within it. What's the sensory receptor that detects rotational movement, equilibrium? It's called the crista ampularis. It's a pretty name, right? Maybe your future daughter, Crista ampularis. All right, so crista ampularis, it's found in the ampulla. So that is basically, if I ask, oh, what's the specific structure here? You're going to call it the ampulla. And then if I ask you, what's the sensory receptor found in there? You're going to say the crista ampularis. Does that make sense?
There's 3 of them?
There should be 3 of them for each rotational plane, right? Yep. So that's the one that has that little cupula we'll find and the hair cells under the microscope. Yeah, so there's one, there's another one here, and there's one probably on the other side of that. So that's that ampulla. And sometimes medicines are found in these little glass ampules that you'll like break the neck off and then get the drop the fluid or whatever. So this is a blow up of the ampulla. Maybe you're asking about this, right? So inside of it is this goopy stuff, that's a cupula. Hair cells are beneath it. And when you spin, there's a bending of those hair cells, and then you have a sensation of rotation.
So what happens is the rocks hit those things and it causes you to feel like you're just
Exactly. Okay. So this is just that crazy small model, but again, it's just the canals versus the ducts here. It's too small to label. You labeled it on the other one, right? So it's kind of it's the same thing. Did you label the cochlea?
No.
Yes. That's for hearing, right? Okay, let's take a break. Let's do 10:30. We'll finish up the list, good specimen, and then we'll dissect. Okay, and we'll have like the remaining 45 minutes.
Will that be on the lab?
Which one, the slides?
Could it be?
Yeah, I'm gonna do some demo slides tomorrow
Okay.
of the things that we've looked at. Okay.
Tomorrow.
Tomorrow
Tuesday.
is
Tuesday?
Friday for the open lab. Yeah, but I'll have them out too for Tuesday.
Okay.
Yeah.
Okay, cool.
Right? Because Tuesday, there's like one more slide to look at. We'll do that Tuesday. And then I want us to have a chance to like look at the otoscope, ophthalmoscope, various things like that.
So
Yeah.
we're gonna do like tongue and face on Tuesday.
Yes. But those are quick. Those are really quick. All right. So did we leave off on this one?
Yep.
Okay. So imagine that you took the cochlea, right, that snail shell, and you sliced it and you'll get something that looks like this. Okay? So remember that snail shell looking deal? Yeah. About 2.5 turns. There's a nerve that comes off the bottom, so what nerve would this be?
8.
CN8, and would be which branch? Cochlear branch, right, because it's coming off the cochlea. Exactly.
There's 4 parts to that.
Well, there's also a vestibular branch that would be coming off the vestibule and the semicircular canals.
I mean, like the tube itself, there's.
What tubes?
If
Like,
you go back to the cochlear ducts. so-
yeah, we'll do that. We'll do that. Yeah. So now, whatever.
We're all 5 here, it's okay.
Okay, if this is like a looks like a big apple with the core in the middle, right? This core is called the modiolus. Modiolus. It's like the apple core. The bony core inside of the cochlea. You see a mushroom? I see that. Now, the very top, it kind of looks like a soft serve, right? Right?
Are you
The
hungry?
very top is called the helicotrema. Is that on your list too?
Yeah.
Helicotrema.
Oh.
Yeah.
36? 36?
Oh.
Helicotrema?
Yeah, okay.
Okay. This, I'd like you to know what happens at that helicotrema. This is where the vestibular duct and the tympanic duct, that's where they meet. Okay? There's 3 ducts, and they are vestibular, tympanic, and then the cochlear. Where these two meet, the meeting of those two is the helicotrema. On the video, you may remember that there was like this uncoiling of the cochlea, right? Like a hat, and it was like, ooh, right? And where the 2 ducts meet is these 2 right here, okay?
And that's the top.
It's at the very top. Very top of the soft serve, right? Right there. Yummage. Okay, so now, there is this bony shelf that sticks out of the modiolus, and it's called the osseous spiral lamina. So it's almost like imagine like a screw, right? That, you screw into a wall, and there's these threads that create this little spiral staircase around the screw, right? And that's basically this bony shelf that sticks out. I'd like you to know that that is the structure that basically supports the basilar membrane. The basilar membrane, that vibrating thing, sits on top of the osseous spiral lamina. There's even a better picture of this. Really where we're going to tag this is probably on this guy right here. It's basically this big jumbo thing. You guys see that? Jumbo. So there's a bony shelf here. It's called the osseous spiral lamina sticking out. And what do you think this membrane that's sitting on top of it that's called?
Basilar.
That's the basilar membrane. That's the vibrating one. We like tagging that one, by the way.
Wait, what?
What? Oh, I must pay attention now. Okay. Right, let me know. All right, so right there, that's the basilar membrane. I think it'll be highlighted in later. Yeah, the basilar membrane, because it's at the bottom, right?
Basically, yeah.
Here, right there. Basilar membrane. Let's jump to 38 real quick. We did the function earlier, but does anybody remember what the basilar membrane do? That's the one that vibrates at different frequencies. Okay. Vibrates at different or specific frequencies. Okay. All right. So osseous spiral lamina. And sitting on top of that is basilar membrane. This is where we're at. Okay. So now, here's another membrane. Vestibular membrane. That's the thin one. very taggable too. Now, does anybody remember what was the bone that pushed in the oval window?
Stapes.
The
Stapes, right? The stapes? Now the oval window will start to push back and forth, yes?
Yes.
That's going to create these fluid waves in this compartment. This compartment is called the vestibular duct. How are you going to remember that? Because it's right next to the vestibular membrane. Okay? So this is this vestibular duct. Let's label that. Okay, so what'll happen in the vestibular duct, it's also called the scala vestibuli. What do you want to call it?
Vestibular duct.
Yeah, either one. So is scala which one's on your thing?
Both of them are.
Yeah, so you can say this scala vestibuli slash vestibular duct.
It's more commonly used.
Yeah, both. Both are interchangeable. Yeah. Okay, so what's happening in here is that you can have waves of perilymph. What's the function of the scala vestibuli? These waves of perilymph can smash up against what? The vestibular membrane. So yeah, so overall, you get waves of perilymph that can cause the bending of the vestibular membrane. All right. So we're basically working our way towards the vibration of the hair cells, right? Some action going on over there. Fire truck and ambulance. Okay. All right, so you get waves of perilymph. That can cause this thing to bend, the vestibular membrane. Okay, now what does the vestibular membrane do?
Translate that to the other.
To now the endolymph. So let's just say when this thing bends, it'll cause pressure waves in this fluid. What's this fluid in here inside? That's going to be the endolymph. So there's peri on this side, peri on the other side, but in this middle compartment you have endolymph. So
Is this
again,
more for
Moves the
fine-tuning
endolymph?
sound, or is this for
fine tuning is more of like these support hair cells in the population, but this is, we're just talking just overall. So again, so vestibular membrane, we said that will bend, that will cause pressure waves in the endolymph.
If we were to just say move the endolymph, is that okay?
Moves the, yeah, so
Move
Yeah.
it.
Yeah.
Okay.
ripples, moves.
And we can see it's the
What's that? These little pressure waves, or they're just waves, in the endolymph.
Sounds like 3. It's okay, I'm sorry.
Alright.
5 maybe.
So that middle compartment with the endolymph, cochlear duct. Is cochlear duct on your list?
Yeah.
It's also called the scala media, right? So either one.
Where am I?
So cochlear duct, scala media, whatever you want to use on that.
Bless you. Bless you.
Okay, so that's the endolymph, right? Why is that endolymph important? When it starts to create these waves, it can cause vibration of this guy. What was this guy again?
Basilar membrane.
Basilar membrane, yeah. So waves of endolymph can cause movement of the BM.
Bowel movement.
That's not your bowel movement, all right? That'll be an A&P 2. Got it, your fiber. All right, so pressure waves in that cause movement of the basilar membrane. And finally, you're like, what is the point of this passageway? The scala tympani.
the exit point?
That's the exit point, right? So movement of the perilymph, or waves in the perilymph. What was that final window that can pooch out?
Circular?
The round window, right? The
Round.
round window. Because it's round.
Right.
Okay. So again, what's the scala tympani? Well, when you get waves of perilymph, what will bump out?
Round.
Round window. So pressure waves or waves in the perilymph in the scala tympani, that will cause the round window to bump out. Okay. Okay, the last couple pictures here is zooming in on this guy. Let's zoom in on that. Did we do helicotrim already? Soft serve. There's a bunch of cell bodies here. I wonder for what cranial nerve?
8.
8? There it is. Yeah. So remember what a ganglion was? Remember like the dorsal root ganglion? There's a bunch of cell bodies. But this is cell bodies for CN8. Yeah, specifically. Okay. So this is the basis of a cochlear nerve implant. As long as you have functional sensory neurons, let's say this person wasn't born with hair cells or whatever, you can stimulate that and the person will be able to hear. Okay?
Wait, they do that?
Yeah, they do that. That's the whole cochlear implant, right? Yeah. They'll jam an electrode into the cochlea and they'll stimulate different populations of the sensory neurons. Bowser membrane, we did that, yes? Okay, let's circle this whole thing, you guys, and call it the spiral organ. Or you can call it the organ of Corti, yes? Okay. Spiral organ, or the organ of Corti, this whole thing. Is cochlear tunnel in your thing?
Yeah.
Or let's nix that. I don't even know really what that does.
I don't know.
So the spiral organ of Corti, or the spiral organ, are 3 parts. We've been kind of talking about these, but we'll recap it right now. So the 3 parts are basilar membrane, right? Remember that vibrates at specific frequencies. And the hair cells. The function of your hair cells, those are your sensory cells. Will they regenerate if they're damaged? No. Nope. Yeah, if they're overstimulated, they get damaged. The apical surface can get like jammed and bumped, right? So you gotta be careful about loud sounds, loud concerts, earbuds, right, that are too loud. Okay. And then lastly, at the very top, oh, look at that. Those are the little hairs. They're actually stereocilia. Is stereocilia on your list? Yeah, that's just the top of the hairs. That's just more anatomical. That's the actual part that bends. So that's really the bendy part, the brushes. So this whole thing is a hair cell, yes? But then just the very top are the stereocilia.
So fortitude, can we just put that they bend?
So they bend. They bend or shear. Okay. And then lastly, what's at the top? So think at the top for the tectorial, bottom for basal, right? Okay. There you go. So top for tectorial, basal for basilar membrane. What's the function of a tectorial? Why do you have to have a surface there?
Does that make the hairs move?
Yeah, you gotta have something to shear. So this is gonna be a mass for bending. Okay? So when you brush your teeth, make sure that the toothbrush actually touches your teeth. Otherwise it doesn't move. Does the tectorial membrane move?
No.
No? But this down here moves, right? When you brush your teeth, do you move your head?
Some kids do.
Like this?
Why not?
Oh, that's my little
You do
dance
that.
back and forth. Okay.
That's why I have cavities.
All right. Is that everything? Yes. Can I show you 2 slides and then we'll do your dissection? It'll take us like 10 minutes. And then you'll dissect. Go to... Did we do the retina?
Yeah, we did.
Yes.
Did we do the cornea?
Yes.
Yes.
Did we do the cochlea?
No.
Okay, that's where we're at. Cochlea. Page 254, yes? Okay. 254? 867?
5309.
Oh, the youngins even knew that. Oh my gosh, made me happy. Have you turned 20 yet?
No, September.
Oh my goodness, really?
Get like a permission slip
Wait.
to take this class?
Not even 21?
the-
20? Good gracious. I'm living my best life through you.
Are you 20 yet?
No, I'm 22.
Oh,
The babies. There's like babies in here.
oh my gosh.
Modiolus, you guys. What happens at the modiolus?
I'm the tough.
That's where these two ducts come together.
Which one is
The tympanic and the vestibular.
in the
Oh! That's on my knee. I'm okay. Alright, that's helicochlear. Wait, no, isn't that?
Did you not ask me helicotuma?
Oh, modiolus.
That's
Okay,
the top of the
modiolus. That was just more anatomical. That's just like the core.
Oh.
The core of the cochlea, right? Okay, sorry.
We say we'll get
I was just never mind.
It's not even a senior moment. What's happening?
Okay, cochlea.
Cocaine.
I'll do a demo. We'll just do a demo on this, okay?
I said cocaine.
Okay,
That's what that sounds like.
let's go for it.
Ayo for yayo.
Cochlea.
Melissa's gonna listen to this and be like, what are you guys talking about?
Has anyone ever heard of the Natomas
Yes, probably.
Performing Arts High School?
The charter school? Yeah.
Charter. Anyone go to that?
I dated go.
Was she smart? Was she smart?
Not very, no.
Aww.
So I was, because my daughter's like getting into all the arts and stuff like that. I'm thinking maybe she should go to like a.
It's a really good art school from what I've
Yeah,
But
I've
then
heard
she
it's a
was
good
not
art
very
school.
smart though.
Huh?
For the performing arts,
I think that's just
Just look
very
smart.
naturally.
like first, like
I went
it's
to a
easier to
great
get
high school.
into than the other part of the school.
There's two.
Oh, there's two parts
Yeah,
to it?
The arts, what is it, performing arts, and then there's another one.
Yeah, like meeting edge or something like that.
Yeah.
That one's like the
The more
academic,
smarter.
Oh, that's the smarter people?
Yeah.
Yeah. I never even heard of that.
Campus in West Campus.
You get her an agent.
Los Angeles.
Okay, let's go for it.
Wait, 10%.
Okay, here's the thing. Let's draw this. Tell me if you guys see like a little soft serve little snail thing. Do you guys see that? Soft
It
serve
doesn't look good.
with the peak, right?
Never eating ours.
Let's draw a version of this. You're never gonna eat soft serve again?
No, thank you.
Yes. I'm going to McDonald's right now.
Oh, yeah.
Right, the machine is working.
Right this second.
Never gonna get Lucas up.
It's a lesson, so I should do that.
Alright, let's draw this
There,
guy.
there, there is.
So there's a top, and then there's bumps, right? Like a rattlesnake rattle. Okay. And then what would be right in the middle, the core of this thing that goes?
Mediolus.
Modiolus, right? Alright. That's modiolus.
There's something everything wrong with you. Quit saying the wrong part.
And then technically, you would find like a bunch of cell bodies in here. What would those be, you guys?
Oh, I don't know.
CNA? And remember what's that called when you get a cluster of them?
Cell body.
Spiral?
Oh, no.
Ganglion.
That was close to me.
A for effort.
Did you do like chain gang instead? Okay. Now, here's the thing. Each one of these structures is actually made up of like 2 different compartments. Or actually 3 compartments. You got like a that, and then a this, right? That is really making up this thing right here.
Does not look like.
Here,
Oh,
let's blow this up now.
I just drew on it.
Alright, when you blow that up, it's really more like this kidney-shaped structure. Like that, okay. this. And then that.
Membranes.
Okay, what's this one that's very, very thin?
The membrane.
Which membrane was that?
Vestibular.
Vestibular membrane, yeah.
Vestibular membrane.
If that's the vestibular membrane, what duct does that have to be?
Vestibular duct.
Very good. That's the vestibular duct. What's on the opposite side?
Basilar membrane.
VD, not not venereal disease, but
Vents or
tympanic duct.
tympanic
How about that?
duct.
And then what would be the duct in the middle?
Cochlear duct.
Cochlear duct. Cochlear duct, yes? All right. Let's correlate this with the actual picture. All right. So the whole thing here is what? The whole ice cream? Cochlea. And then this middle thing, modiolus. And then do you see clusters of cell bodies?
Yeah.
Spiral ganglion, yes, you get it, right? Makes sense? Okay, now, I want us to like blow up one of these chambers. Do you see the kidney-shaped thing right there? It's just like my picture. Kinda. All right. Do you guys see the thin?
Yep.
Yes.
Vestibular membrane. Yep. Which would make this the
Vestibular duct.
vestibular duct. Opposite side,
Tympanic.
tympanic duct. Okay. Isn't that crazy? All right. Let's zoom in on the cochlear duct in the center.
This will work.
Check it out, you guys.
Can you select the hairs and stuff?
So now, what would be at the top? Kind of looks like the Italian boot there, right there. Boom. Okay. And then, yeah, like a boot. And then what are these? That's boot. And then what about these cells here? Hair cells. And then what's at the bottom? Isn't that crazy? How the anatomy is really similar to what you're going to see on the models.
Fall down.
So that would be your, at the bottom, basilar membrane. Right? I mean, there's probably a couple hair cell populations, but we're just going to focus on the one at the very top, really, right? Use your imaginoscopes. It is kind of, kind of fuzzy at the top. And then there's this little structure that will stick out. What's that little top membrane called? Tectorial membrane. Tectorial membrane. Yes?
See.
Awesome.
How did he slice it that thin? It's out of curiosity. I mean, that's pretty.
It's a microtome. It's these diamond knives that are super, super thin. Yeah, and they're so thin that they want to peel off. I used to did some of them in the Bay Area. They're just like,
Peel off.
yeah, because they're so thin. Yeah, I mean, it's beautiful though when you look at the structure, right?
Oh, yeah.
Yeah. All right. 3 chambers, yes.
Uh-huh.
Okay. Whole thing's the cochlea, and in the center there is the modiolus with the spiral ganglion cells. Yes. The main cells really are spiral ganglion and the hair cells. Those are the 2 hair cells, or I'm sorry, 2 cell populations, and then think about the different ducts, right? Duck,
Goose.
duck. I know, I kind of led you there.
I
All right.
I'm a sucker for that.
We're like so brainwashed, right? Remember all like the commercials that were catchy back then? Now they don't have those anymore. Okay, can we go to the vegetable, the vestibule? Go to the vegetable. Top of 255. Are we in your lab manual?
Yes.
255er. Okay. Do you have rocks in your head?
Yes.
Let me prove it.
Bless you.
Oh, don't have a stroke.
Oh my gosh.
I know, yeah. I guess this is the time to have one, huh? We got the ambulance here. Gosh, terrible. 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 That is sparkly. Okay.
Chuck?
Actually, you guys ready for the rocks?
Rocks.
Had like a box of rocks. Okay.
We're gonna headbang.
Okay. Here's the thing. You see that? That looks like nothing.
Yeah.
Okay. Let me zoom in.
Man, my math is such a good today.
Small rocks.
Crystals.
A lot of rocks. Crystals.
The crystals.
Jaime, can you show me the crystals?
These are the crystals.
Where'd
Yeah.
you go?
Get away. Get up the brightness.
Yeah, there we go.
Pump up the volume.
No, wait.
Oh my gosh.
Oh, those are
Oh, that's
like flashbacks to when we first started using the makeup.
hard to see.
Okay. You guys see crystals?
Kind of.
No.
These are the rocks in your head, you guys.
Which one?
The dark
Right there. Right at the top.
Oh, okay.
Yeah.
Cool.
It's just they look like little coffee grounds. Yeah.
And when those come loose, these cause a nightmare
They
experience.
cause nightmare experiences. Isn't that crazy? So this is the top of 255er.
Never get that.
Crystals. The moral of the story, you guys, don't get old.
Die early.
Okay, drop some crystals.
So do those just break off with age?
They just break off with age or trauma.
Oh.
Yeah. Okay. What are the crystals called?
Rocks.
Oto?
Lifts.
The ones that you have out here.
Okay.
Yeah, it's like we.
There's a membrane
O2
that they
lift
sit
membrane.
in. Have you ever made Jello and put some apple in there?
No.
Same thing. Okay. There's a little membrane. So everyone's gelling. Okay. And then down here, again, there's probably a couple rows of cells. Like so. I really should have had the little tips like embedded.